that the astronauts read out.
Gravitational effect of those planets.
Hi, I'm Chris, and this is NASA Now. Imagine the coldest temperature on Earth. Now, go a couple hundred degrees lower than that. Our expert today explains why NASA researchers study fluids and materials at super cold temperatures for applications in space. That's ahead, but first, here's what's happening at NASA now. Space Shuttle Discovery arrives at its new home. After 39 missions, 365 days in space, 5,830 orbits of Earth, and over 148 million miles traveled, Discovery reached its final destination. A NASA-modified Boeing 747 carried Discovery on its back during the transport to Washington Dulles International Airport. Discovery will be on permanent public display at the Smithsonian's National Air and Space Museum Stephen F. Udvar-Hazy Center in Chantilly, Virginia. Just how cold is cold? How about negative 269 degrees Celsius or 4 Kelvin? That's the temperature you'll find in some parts of space. Today, our expert Wesley Johnson from Kennedy Space Center will talk about the use of super cold liquids and insulating materials for space exploration.
Cryogenics is the study of both fluids and materials at super cold temperatures, as cold as absolute zero and sometimes going up to about negative 190 degrees Fahrenheit. Some of the applications that we use cryogenics here at NASA involve liquid propellants for launch vehicles. We use liquid oxygen and liquid hydrogen, both which are several hundred degrees below zero, in all of our propulsion applications. This is some flowers that I picked at my house this morning. They were bendable and pliable. In fact, they were alive this morning when I picked them. So now we're going to put them in liquid nitrogen and see what happens to them. So when I chilled down the flower, the properties of the molecules in the flower changed and they became very brittle and it broke apart. Some of the applications that you might see cryogenics here on Earth are on MRI machines, which use liquid helium, which is even colder than liquid hydrogen. The liquid helium is wrapped around the superconducting magnet as it takes high-intensity images. Also, most cell phone towers have a liquid nitrogen cooling system to allow for better reception and wider transmission ranges. What we do at the Cryogenics Test Laboratory is we develop insulation systems for ground applications here on Earth and also for spaceflight applications in orbit. On Earth, there's 3 modes of heat transportation. The first is just solid conduction along any solid material. The material has an affinity to conduct heat. The second is called convection. It's caused by gas motion, where the gas can pick up the heat from a solid object and then leave. The third mode is called radiation, and this happens both on Earth and in space. In fact, it's the only mode of heat transportation in space. Radiation occurs when electromagnetic waves travel between a high temperature system to a different low temperature system, and this can happen through a vacuum. So for in-space applications where we only have to deal with radiation, we use what's called multi-layer insulation. And that's just like this highly reflective blanket right here. And you can see this spacer material in between it that we use to keep the reflective layers from touching each other. Just for instance, this blanket in my hand has 25 layers. 25 layers of reflector and 25 layers of spacer material. On Earth, we use a couple materials. One type of material that we use is these aerogels I have in my hand. I have a powderous form on my right hand and a blanket form on my left hand. Aerogel is the best thermal insulation that we have on the Earth right now in an atmosphere. And it was also actually developed here in the Cryogenics Test Lab at Kennedy Space Center.
Shielding a craft from the extreme temperatures of space is a real challenge. See how well you can do with this project.
Teachers, you and your students can develop your own thermal protection system with this featured lesson. Look for heat, temperature and energy, messenger, cooling with sunshades. You'll find it on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.